This is the solution video for the mixed algebra revisions. It's a bit of everything on this one. First question is expanding a binomial expression. So we're going to use our NCR button in this calculation. And we'll be starting out with 5 to choose 0. We're putting the first term to the power of 5 and the second term to the power of 0. And then it's going to be steps of the stairs. So it'll be 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5 for that term. And we'll be increasing our value here, 5 choose 1, 5 choose 2, etc. as we go along. And I can just do a quick double check at the end to make sure that everything looks okay. Patterns wise, 0, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. So everything's got the right power. Notice I've put brackets around everything that I filled in, and I put a plus at the start of each line to link the entire expression together. Now I'm going to tidy up and do a little bit of evaluation. It's particularly important in these kinds of questions that you keep the power outside the brackets as you're filling in order to make sure that you get the correct sign in the bracket with the negative number. So you can see, for example, here I've got a negative to a power, and the signs are alternating: positive, negative, positive, negative, positive, negative. Now my last step is going to be just to take all of this and tidy it up into one answer. Watch out for signs, multiply coefficients, combine any necessary variables. On we go to question 2, which is simultaneous equations. Good idea here is to name the equations at the beginning so that you know which ones you're dealing with and it's clear to the person reading your work. And you can also use that then to indicate what changes you've made to each equation. When I look at the A and C equations, I see that the C terms match up exactly. Signs are already different, so I'll take those first and knock out the C's, and then I'll get an equation with A and B. I'm going to call this new equation D. If I double up that B equation, I'll have a similar scenario with 2 C's I can cancel off. Again, notice how I wrote in at the side what I was going to do just to make it more obvious, because these can be hard to follow otherwise. And then I'll match everything else together and I'll call that new equation E. So I'll use D and E now together to get A and B. And now I can get A, and I'm just going to highlight that to make it easier to see at the end. Then I'll sub that back into D or E, whichever one looks nicer, to figure out B. So now I've got A and B. Now just to find C by going back to one of the originals and subbing A and B back in. I think A looks like the nicest probably. Actually, no, maybe B, because the C is by itself. And again, just note that I've labelled which equation I'm filling into. And no harm to just sub those back into the A, B, C equations to be sure that they're giving you the correct totals at the end, to be convinced of the correctness of your final answer. So question 3 then is about writing a quadratic in vertex form and hence identifying its turning point. So I've got my quadratic there. I'd like to write down the general form of vertex form, kind of to know what I'm aiming for first. So this is how vertex form looks. You'll see some variations on this format. Sometimes you'll see a minus here. It doesn't actually matter which one you use as long as you follow the instructions of the question and you remember when making the vertex point to change the sign. Don't change the sign. We'll see how that goes over the course of this question. So I'm going to use algebraic identities to solve this, and I'm going to equate the original quadratic to the vertex form, and I'm going to expand the vertex form. So I'm squaring out that x plus p, and then I'm just multiplying out that a on the right hand side, and now I'm going to match up like terms effectively. So I'm looking on the left hand side at the x squared terms first of all, so their coefficients will be equal, so that's grand, a equals 5. Moving on to the x terms, I could say 20 equals 2ap, and you'll notice that I'm not actually writing down the variables here at all. I'm just focusing on the coefficients of those terms. And I already know a. When I manipulate this slightly, I'll see p is 20 over 10. That's just a 2 by 5. So p is 2, and then I'm going to take the constants on each side and equate those. Now, on the left-hand side, I just have the 27. But on the right-hand side, both of these guys are constants because there's no x, no variable at the end of them. So I must take both of those into account in my last little equation. And again, now I've got some of those values. I've got the a and I've got the p. I'll fill those in. So I have my a, my p, my q. Not finished quite yet. I still have to write it in vertex form. That's going back up to the sky again. A bracket x plus p squared plus q. So I just have to fill in the a, p and q. So there's my vertex form filled in. And then they want to know what the turning point is. And this is what I referred to at the start. Watch out that you're careful with your signs. So you're going to use these two values to figure out your turning point, and you'll change the sign of this guy. So whatever it happens to be in here, you'll reverse it. And for this one, you'll just keep it as it is. So it's already a plus, I'll leave it as a plus. And there's your turning point. Question 4 next. So for which values of x will the roots of this quadratic be real and equal? Well, it's a quadratic, but everything's kind of a little bit jumbled up currently. I'm going to put everything in the right place to begin. So my terms are in the correct locations. And now I'm looking at that quadratic having real and equal roots. So when I see anything about real and equal roots, I want to think about the discriminant. And the discriminant is b squared minus 4ac. And for the condition of real and equal roots, I want that to be equals to 0. No harm here to stop and take a moment to think to yourself, do I know what the other conditions are? So what would it look like if I just had real distinct roots? What would the discriminant look like if I had complex roots? If that is lost from the memory, maybe go back and look it up and remind yourself. So to fill in my discriminant, I'm going to fill in my a, b, and c. And again, for this case, the discriminant will be equals to 0. So I'm going to want to solve out this little equation now, and then I'll have my answer. So the first thing to do is just multiply it out. And if you like, you can divide across by 16 at this stage, or alternatively, you can proceed with your factorisation from here. It's going to be a difference of 2 squares either way. I'm going to divide. You'll get the same answer if you don't. There's my factorised brackets, and then I want my values for k. So k equals minus 3 and k equals plus 3. And just notice in the question they talked about values of k, so they kind of give me a hint that I was expecting to have 2 answers there. Okay, question 5, rules of logs. Now you need to have your log tables obviously open next to you on page 21 when doing this question. And we'll see first of all that, okay, we've got addition, but I can't use it yet because I've got a coefficient in here. It needs to be log 3 something plus log 3 something before I can use the addition rule. That's rule 1. I've got this 2 out in front, so how could I sort that out? Well, if I've got a coefficient and a log, you'll see in rule 3 that I can bring it up and put it as a power on the x. And at this stage, you might start suspecting that maybe a quadratic is in the offing, and it is. So, okay, so on to rule 1 then, where I've got the addition. Okay, so now I've got log 3 something plus log 3 something, nothing in the way at the start of either of those. I can use that multiplication rule. And now, since I've got one term each side, because each side I've got a log base 3 of something, I can just get rid of the log base 3. And now the quadratic is fairly apparent. Okay, so factorisation solution at this stage. I'm not going to go through the stages of the quadratic. You all know how to do that. I'll just give you the brackets. So we've got 2x minus 1 by x minus 3 equals 0. We get our 2 solutions. At this stage, in any log or exponential question, and in a lot of other ones also, it's a good plan to go back and just double check that your answer makes sense or that it doesn't cause any problems. Remember that if I've got a negative in any of these positions here in my logs, then I'm going to have to ditch that answer. So let's check the 3 first because that's easier. Okay, 3 is positive, no problem. 3, that'll be 21 minus 3, that's 18 in that position. Positive, no problem. Let's check the half. Yeah, a half, it's a positive half, so a half can go in there, that's fine. And you put a half in here, you get 3.5, 3.5 take 3 is a positive number. That's fine, I can take both those answers. Job done, on we go then on to question 6. So in question 6, I've got an exponential equation. And again, it looks a bit reminiscent of a quadratic, so maybe it's going to spit one out. Let's have a look through the individual terms. In that first term, you might notice that I've got multiplication in the exponent. So I can actually split that term up and write it as 2x all to the power of 2. And you can see here that the 2 to the power of x is in the position that you'd normally have your variable in a quadratic. So just to make things a bit more visually nice for ourselves, let's do some substitution. I'm going to replace all those 2 to the x's with y. And now I've got a much more obvious quadratic that I can factorise. And then onto my solution. So now I've got 2 answers for y, but it's important not to stop here because I'm not quite finished yet. Remember that the question was asking you to solve for x. So I've solved for y, but I haven't got my x values yet. But let's remind ourselves that y was 2 to the power of x. So I can just replace y's with 2 to the power of x. And then I can just solve each of these. And actually these are pretty nice ones. All I have to do is get the same base and I can work off the exponents. So my first solution is x equals 2. And my second solution is x equals 3.